So for number 4 in the checkpoint, we have x squared minus 12x plus 4 is equal to 0. And the reason we're completing the square is because this can't be factored. So when a problem can't be factored, we have another method to use so that we can still solve for x. So Holly, what would you do first with number 4 to find complete the square? Yeah, so we need to take the 4 to the other side. And we have x squared minus 12x, so negative 4 is on the other side. What do we do next, Holly? Right, so we have negative 12, we're dividing that by 2 and squaring it, and that gives you what number? 36. So you're adding 36 on the left, but don't forget to do that same thing to the right side. To keep the equation equivalent, whatever you do to the one side, you must do that same thing to the other. So we're adding 36 on the left, but also adding 36 on the right side of the equation. So over here, this becomes x minus 6 squared. That's the perfect square part. So we've made it a perfect square by adding this extra number in it so that we can then factor the one side. And Holly, on the other side, negative 4 plus 36 makes 32. So that's completing the square process. The rest of it is solving like we solved using the square root. So the reason we're completing the square is so that we can then solve by taking the square root of both sides. Because now that's really the easiest way we can try and get x by itself. So the reason we take the square root is to cancel the root and the square term. Maybe. Gavin, does Mr. Cummings have problems with the Apple TV when he's in here too? Yes. It's not just me and my MacBook. So frustrating. Okay. So then we just have x minus 6. And on the other side, we have the square root of 32. Hunter, can you do anything with the square root of 32?
Bring it down to the square root of 16. That's 32.
Yeah. So 16 and 2. Remember, you want the largest perfect square that goes into 32. So plus or minus, because we took the square root to solve for x to get it by itself. And then we have 4 and the square root of 2. So when you take the 6 to the other side, it's a positive 6 because we have to add it, and then plus or minus 4 and the square root of 2. Are there other questions that you have from the homework with completing the square, getting that number to add in for C? So we're going to look at, I think, 3 other problems, maybe 4. Remember how many's down here? It's like 2, 3, 4 problems. And we're switching it just a tiny little bit because now we're going to have a number in front of the x squared. So it's just slightly different because of this number sitting with the x squared. So if you notice, we have 3x squared minus 12x minus 27, and that's equal to 0. It says solve the expression by completing this square. So what do you think you would do first to try and solve this expression? Melanie? Yeah, why would you want to do that?
Because they all can go in 3.
Yeah, they're all divisible by 3. So what do we call that? Do you remember what that's called when they're all divisible by the same thing? Julian? Yeah, they all have a greatest common factor. So when they all have something in common, we can take that number out that they have in common. And that's the first step that you would want to do. So when they have something in common, we want to take that value out. So she said divide them all by 3. Technically, you're dividing both sides by 3. So you're dividing the left by 3 and the right by 3. Even though there's a 0 over there. If there was something else on that other side, we would have to make sure we divide that by 3. So Melanie, when you divide by 3, what do you have then?
X squared minus 4x minus 9 equals 0.
Equals 0. So if they have a GCF in common, we need to take that GCF out. And that's with factoring too. So when they have a GCF in common and we're factoring, we take that number out. We're doing the same thing here with completing the square. And then the process works like we did above. So we divided that number out. And now we're going to complete the square. So we'd add the 9 to the other side. That third value, we're always moving to the other side. So that we're looking at x squared minus 4x. So Maddie, what number goes in place of where the 9 was sitting?
1 divided by 2.
So negative 4 divided by 2 squared is 4. So we're adding a 4, adding a 4. And then Maddie, on the left side, how does that factor?
X minus 2.
Yep, perfect. X minus 2 squared. So completing the square is a process in order for us to get a quantity that's a perfect square so that it can be factored. And now we can solve this by using the square roots. Can the square root of 13 be broken down? No. So square root of 13 stays as a square root of 13, just put a plus or minus in front of it. And then take the 2 to the other side. So 2 plus or minus, and then the square root of 13. So see if you can solve letter B. 3x squared plus 36x plus 150. Here, what's the GCF for letter B? And if we divide everything by 3, what do you have left?
X squared plus 4x.
So after you divide by 3, GCF, take that 50 to the other side. And then Garrett, we have 12 divided by 2 squared. So what number are we adding in? 36, nice. So 36 on the left side, but also 36 on the right side. And then how does it factor, Garrett? Nice job. So the left side is x plus 6 quantity squared. The right side we have a negative 14. And now the problem is like all the other problems that we've had with those quantities squared. Take the square root of both sides. This one has a negative with it. So when you pull that negative out, the I goes directly in front of the square root of 14. The plus or minus is in front of the I. Because the negative was underneath the square root, so you pull that out, creating the imaginary number, but it goes directly in front of it. So subtract 6 to the other side, and then plus or minus I square root of 14. Questions? So the two other types of problems we're going to do are slightly more application-based. The one is trying to take an equation, and currently this is in standard form. So now we're going back to a parabola, thinking about a parabola. It wants us to change it to vertex form, and then identify the vertex and the axis of symmetry. And then the last problem we'll look at is a little word problem. So we always have to throw in that little word problem and see how that kind of works for what we're working with, how we're solving the problems. So we have y equals x squared plus 14x plus 44. And it says write it in vertex form. This is a nice little review to start kind of thinking about those graphs that we did a couple weeks ago. Vertex form is when we have a number in front, and then we have x minus h squared, and then we have plus k. That's a vertex form, where the h and the k are in the problem. We have a parenthesis or quantity squared. We're going to use completing the square to help us get it in vertex form, because completing the square gets a problem to have parentheses squared. So if my problem has a quantity squared, that's when it's in a vertex form. So we're going to kind of do it the same exact way, except we have a y in the problem, which is okay. The y is going to stay there. We're going to still take this 44 to the other side, but I'm going to take it so that it's with y. So I'm going to subtract it, so we have y minus 44, x squared plus 14x. So you're still taking that extra number to the other side, except right now it's just sitting next to y, since there's a y over there. So the next step would be to try and complete the square. Emma, what are you using to try and complete the square here? And 14 divided by 2 squared is? 49. So we would add 49 to complete the square. On the other side, we would add 49. So that part isn't changing. The only difference is this is now an equation as a y equals. It's more of a function form that we would graph. So continuing completing the square, on the right side, x squared plus 14x plus 49 becomes x plus 7 squared. On the left side, negative 44, positive 49 make a positive 5. Emma, what will we have to do to get this in vertex form? Yeah, so we need to get y by itself essentially, so that vertex form has the x minus h squared and the k on the same side. So we would subtract the 5. We have x plus 7 squared, and then minus 5. So we're not solving, because it's not equal to 0. Instead, we're just trying to get this to look like an equation that's in the vertex form of a parabola. So we have that quantity squared, and then this extra number over here with the plus 5, we need to take it to the other side, so y is by itself. It asks us to find the vertex and the axis of symmetry. So on your chapter 4 test, you won't be asked to completely work through one of those huge problems in graph. Instead, you might be asked to find the vertex, the axis of symmetry, the y-intercept. You might be asked to find parts of it. But you wouldn't have one full problem because we've done 2 quizzes on those, or a test and a quiz on that information. But you're still going to be asked to identify parts of the parabola. How do you find the vertex of the parabola when it's in vertex form? Julia? It is h and k. So the numbers in the equation represent the vertex. That's why it's called vertex form. So Julia, this vertex would be? Right. The trick is that you need to remember, even though this is a plus 7 inside, this is really a minus negative 7. So the graph is shifting to the left. The vertex is going to negative 7 and then negative 5. H is always the opposite. The axis of symmetry is whatever the x value is in the vertex, and that's just negative 7. You don't have to do any work after you have it in vertex form. You've done the work to get it in vertex form. The numbers in that equation represent the vertex and the axis of symmetry. So the vertex is negative 5, negative 7. The axis of symmetry, don't forget that x equals negative 7. Questions? Alright, so little application problem on the next page. And this one's a little different, not quite as nice as the other ones that we've been working on. It says the height y in feet of a baseball, t seconds after it is hit, is given by this function. We have negative 16t squared plus 64t and then plus 5. It wants us to find the maximum height of the baseball. So the baseball was hit. And it goes up, comes back down, it's going to land, somebody's going to catch it. Our goal is to find the maximum height. The maximum height and the vertex are the same exact thing. So if we want to find the maximum height, we also want to find the vertex. They go hand in hand. So a parabola's max is at its vertex. In this problem, we have negative 16t squared plus 64t plus 5. The other two problems that we did on the previous page, I'll show them to you again, they were both divisible by 3, but every single piece of it was divisible by 3. So we could just divide all of those pieces by 3. This problem has a negative 16 in front of the t, or in front of the x, however you want to think about it. But if we divide by negative 16, this 5 doesn't have a GCF of negative 16. It's a 5. And if we divide it by negative 16, then we have negative 5/16, which is not really a nice number to work with. So instead of dividing first, we're going to try and make this problem work for us by taking the 5 to the other side. Because it's not divisible by 16, so let's just pull that number to the other side. So y minus 5. So sometimes you have to make the equation work for you. So now if you look on the right side, negative 16t squared plus 64, those have a GCF. And when things have a GCF, you can take that number out, but still keep it in the problem. And that's when you do when not everything is divisible by a number. So only the one side is divisible by 16, but not the other. So we have to keep it in the problem. We can't literally divide it out. On the left, this just stays as y minus 5. So that part's not changing. So Will, if we take a negative 16 out of negative 16t squared plus 64t, what do you have left in the parentheses here? So negative 16 divided by negative 16 is 1. So that's just positive t squared. 64 divided by negative 16 is negative 4. Now notice I didn't take the t's out of the problem because our goal is to complete the square. And to complete the square, we need to still have a variable that's squared. So I know they both have t's in common, but we can't complete the square if we also pull that out. So we're only taking the number that they have in common out so that we can try and complete the square. And I'm going to leave myself a little more space here. So now we're completing the square, but we're going to use the numbers inside the parentheses. So that negative 16 is sitting outside. We're going to place a number inside that parenthesis when we take negative 4 divided by 2 squared, because that's the process of completing the square. So we're still doing that process, we just have to tweak it a little bit. So Julian, negative 4 divided by 2 squared is 4. All right, so here's the little trick. We're supposed to place the same number on the left, actually the right and the left of the equation, to keep it equivalent. We need to add something to this left side of the equation so that it's the same exact number that's on the right side of the equation. What number would we add to the left side of the equation? Julie? Why is it negative 64? Exactly. So because this positive 4 is plugged in here, but that positive 4 really is being multiplied by negative 16 because we pulled a GCF out. So when you place that number on the other side, we can't put a positive 4. It's really positive 4 times negative 16. And he said that would make negative 64. So that's the little difference if you have a number sitting outside. They all don't divide nicely by a number. So this becomes y minus 69. Keeping the negative 16. This is still factorable because we made it a perfect square. It's t minus 2 squared. But we're adding a 4 on one side, but really to keep it equivalent on the other side it's 4 times negative 16. And then getting this in vertex form, negative 16 t minus 2 squared, and then plus 69. It's a little harder because it doesn't divide evenly. So we said the max occurs at the vertex. Abby, what is the vertex of this equation? 2 and 69. Which one of those would represent the maximum height of the ball?
69.
Right. So the maximum height of the ball would be 69 feet. This number here represents the time that it takes. So after 2 seconds, it's reached its maximum height of 69 feet. So the x is really the time, because that's our variable in this problem. The y would be how high it is at that amount of time. Questions? So I'm going to stop there. I know there's like a couple of extra review practice problems, but we'll stop here. So I have a worksheet. You can, I'll send you the answers through Remind in a minute. I'll get them right now. You can do the work on the back of the page or on a separate page, but do not squeeze them on this paper. There's no space to write those in between. So on this page, I'd like you to do 1 through 31 odd. And 27, 29, like that would be from the new group of problems that we looked at, getting it in vertex form. 21, 23, 25, those are the ones that have that number in front. So if they don't have it in common, if it's not, everything isn't divisible by it, then you're gonna have to try and do it like this last problem here. And it looks like that would be maybe number 23. Might be similar to this last problem here where you're taking a GCF out of only just a part of it. So you have about 10 minutes actually. 8:08 goes to 8:18. So we have 10 minutes. Get a head start on this. Tomorrow we're learning the last way to solve equations using something called the quadratic formula. So that'll be the last method that we talk about to solve equations. And then we have just like Thursday to kind of wrap up the chapter. Again, those review worksheets, the test buyback, please get those into me tomorrow so I can grade them and give them back to you so you can redo the test, retake the test if you'd like to do that. Good way to review for your chapter 4 test next week too.